Hello guys, what's up? We are back again with another question from our DSA challenge series, Level Up series. So let's get started. So guys, today our question is find all possible stable binary arrays, part 1. And definitely we will look into part 2 as well, which is a hard follow-up question of this, hard mark follow-up question of this tomorrow. So now let us see how we can solve this. So this question states that find all possible binary arrays, and it is of course part 1. Now, a binary array is called stable. We need to find stable arrays whose number of occurrences of 0 in the array is exactly 0. Number of occurrences of 1 in the array is exactly 1. So 0 and 1 will be given to us in the question. And the number of zeros in our modified array or the constructed array should be equal to the number of ones in our constructed array. Now each subarray with a size greater than limit must contain both 0 and 1. Okay. Yes. Now we need to return the total number of stable binary arrays. So this is the most important condition, which states that each subarray ARR size greater than limit must contain both 0 and 1, which means that we cannot have a subarray which have consecutive number of zeros or 1 greater than limit. For example, limit is let's say 2. Okay, so we can see that limit is 2. So I cannot have 0, 0, and again a 0. This will be invalid for sure. So my task is to return total number of stable binary arrays which I can find. So what is a stable binary array? Which contains exactly given number of zeros and given number of ones, and no subarray contains no contiguous subarray. Of course, subarrays are contiguous. No subarray contains either greater than limit ones or greater than limit zeros. So let us see how we can solve this. So clearly, the question boils down to selecting 0 or 1. And selection from two ways gives a direct indication of we need to apply our DP there. So now let us see what we actually need. So we need number of zeros in the array till now, number of ones, yes, number of ones in the array. Also, we need what is the consecutive, what is the current element state which is going on. Of course, the limit which is given to us the question, and yes, a count which denotes that yes, okay, you are in the limit or not. So this way, we need to think of something of a solution. Just a second, which satisfies this. Now let us see the solution. Yes. So what I know is that if my ones and zeros, I will try all possible ways. So I will start recursion, definitely. Initially, my one count will be given, one only. My zero count will be, which is given in the question. My current will be 0 or 1. So current is at present, which element I am looking at. So I have two possibilities there, either a 0 or a 1. So I have to consider both, starting from both. Okay. Now there is a limit which is given in the question and the D. So if it could have been a 4D DP, it is an optimized version which I am showing which has also a current taken element. You can say that. So but we can improvise that in terms of space, not in terms of time. Actually, in this code, we basically manually handle that. I will show you. So now what will be my base case? I need a array such that both zeros and ones both reach to their limit, or you can say when both are exhausted, then I will return a one. That means I can say that I have made the array. And of course, limit condition, I will ensure in the while selecting itself. Hmm. So this is just a memorization condition. DP of 1, 0, current. So these three will be my states. 1 indicates the count of ones. 0 indicates the count of zero taken, or rather not taken. Yes. And current indicates the current index, whichever I am. Now, if I am at current index 1, so in this code, what am I you know saying is that if I took a element 1, yes, if I took a element 1, then I will try for all possible ways. I will try for all possible ways up till limit what I have of placing it. What do you mean by what I mean by that is, let's say I am here at 1. I selected 1. Okay. Then now I will iterate from I is equals to 1 to the limit, or minimum of limit, and what number of ones I have. I will iterate, and I will try to find out, how many I can place. So up till that index, I can say that, or up till those many ones I placed, and then I pushed the current element as 0. So essentially what I did was I took 1. Now I can take 1, 1 also, 2 consecutive ones. Let us say my limit is 3 and I have enough number of ones. Uh, so I can take 1, 1, 1 also. Yes. So now I took 1. So what will be my current element now become? I took 1, 1. So I should place now a 0. I took 1, 1, 1. I should place now a 0. In 4D DP, this case was not manually handled here using for loop. In that case, we simply took the element and then passed on for both 1 as well as 0. We took the element and then, okay, let us pass it for 1 also. Let us try it for 1 and let us try placing the next element as 0 also. No problem. But in this case, we are trying all possible ways of placing 1 at once. At once, we are trying all possible ways of placing 1. And then 0, and we are setting the current element as 0. Similarly, we will do it for 0. So if my current element is 0, that means I have to place 0 now. So I can place 1, 0. I can place 2 consecutive zeros. I can place 3 consecutive zeros depending upon how much limit and how much 0 count I have. So I will try all possible ways and then I will send off a 1. So yeah, this is the simple basic approach, and we will simply return DP of 0. So in the next video, we will convert this. First of all, we will convert this into a tabulated version, and then we will see how the tabulated version needs to be optimized in order to pass the test cases of the hard version of the problem. So in this video, that's all from our side. Thank you so much, guys, for watching this video. Just in case you missed it, I will summarize it once again. So the question was that we need to make a binary stable array in which we should have these number of zeros, these number of ones, and a limit is also given. And I need to find what? And I need to find out the number of stable arrays possible. So what I did, I started from, I made a recursive function and I with states as ones, count of zeros, current element. Of course, we will have a limit given as the question under DP array. So I can start with one also and zero also. So I took the cases separately. And then what I did, I just went through the code. I just tried. If my current element is 1, then I try placing all possible ones, which I can, with my current element as 0. Similarly for 0, I do that. And finally, I store my answer in the DP form. If it is already p-computed, then I can return. That is a basic rule of memorization. What will be its time complexity? Yes. So its time complexity will boil down to once we are traveling, zeros we are traveling, and then limit also, limit times also. So nearly n cube. Yes, nearly n cube will be the time complexity. And we are using a 3D DP. But yes, the third dimension is only of 2 size. So nearly n square. N square is my space complexity. And this one is my time complexity. So yeah, guys, this was all. Thank you so much, guys. We shall see you next time.